Greetings to everyone. My name is Romania, Assistant Professor in Electronics and Communication Engineering from Mahindra Engineering College for Women. So today we are going to discuss about one topic in transmission lines and RF system. So the specified topic is line constants for zero dissipation line. So this comes under the unit 2 high frequency transmission lines. So the line constants for general transmission lines are series impedance and shunt admittance. So what is series impedance? So already we denoted in the symbol of Z. So the Z is equal to R plus J omega L. So that is the combination of resistance and inductance. So another one is shunt admittance. So Y is equal to G plus J omega C. So shunt admittance is the combination of conductance and capacitance. So now we have to find the condition for zero dissipation line. So by using the skin effect, we have to derive some conditions. So the conditions are R value, that is resistance value, is completely negligible with respect to inductance. So and also the conductance value should be equal to 0. So by using this condition, we have to find out the line constants. So first one is characteristics impedance. So what is the formula for characteristics impedance? So that is equal to square root of Z divided by Y. So already we know that what is Z? Z means series impedance, Y is shunt admittance. So we know the value for Z is equal to R plus J omega L. So Y is equal to G plus J omega C. So now what is the value we will put by using the zero dissipation line condition? So now we have to put or substitute R is equal to 0 as well as G is equal to 0. So we will get the final value is square root of J omega L divided by J omega C. So here J omega term getting cancelled each other. So finally we get Z naught is equal to square root of L by C. So here characteristics impedance is directly proportional to the inductance and inversely proportional to the capacitance value. So now we have to move on the propagation constants. So what is the propagation constant? So already we know the formula for propagation constant. So gamma is equal to square root of Z and Y. So the same condition will be applied here. So what is the value for Z? 0 plus J omega L. So and Y is 0 plus J omega C. So we will get J omega L into J omega C. So now we have to multiply each other. So we will get J squared omega squared into LC. So now we have to take the square term in the outside of square root. So what is the final value we will get now? J omega square root of LG. So propagation constant value under the zero dissipation line or dissipation less line is equal to J omega into square root of LC. So already we know the formula for propagation constant. So that is the combination of attenuation constant and phase constant. So we will equate the real and imaginary part from the gamma value. So what is value here? A real part alpha is equal to 0. So here there is no attenuation constant. So beta value will be equal to omega into square root of LC. So by using the formula, we will find the velocity of propagation and wavelength. So what is the velocity of propagation? So that is equal to omega divided by beta. So that is equal to omega divided by, so what is the value of beta? Already we found the value for beta, that is equal to omega into square root of LC. So omega divided by omega into square root of LC. Now we will cancel the term of omega. So omega getting cancelled each other. Finally we get 1 divided by square root of LC. So the velocity of propagation depends on the inductance and capacitance. So final one is wavelength. Okay. How do we find the wavelength? So already we know the formula for wavelength. So wavelength will be denoted as lambda. So lambda is equal to 2 pi by beta. Here beta means phase constant. So we will substitute the beta value over here. So 2 pi by omega into square root of LC. So 2 pi getting cancelled each other. So finally we will get the wavelength value of transmission line is 1 divided by f into square root of LC. So the wavelength of transmission line depends on the frequency, inductance and capacitance. So that's all about the line constants of transmission line under the condition of dissipation less. Thank you.